Today in this video lecture, we will discuss Simpson's one-third rule of integration. Before going to the Simpson's one-third rule of integration, let us go through basic idea of integration. That is, what is integration? So integration is the process of measuring the area under a curve, and mathematically it is expressed as I equal to integration f of x dx, and this fx is the integrand and a and b are the lower limit and upper limit of the integration. Let us represent it with graphical representation. Let us suppose this curve represents the function fx. Along the y-axis we have the function value, and along the x-axis we have the variable x. We suppose that f of a and f of b are the value of that function at its lower limit a and its upper limit b. So now within this limit, if we can calculate the area under this curve, then we will have the integration of that function within these two limits. Now Simpson's one-third rule is basically an extension of the trapezoidal rule, where integrand is approximated by a second order polynomial. Since in your syllabus there is no trapezoidal rule, so we will not discuss about this trapezoidal rule. We will directly go to Simpson's one-third rule. Remember, this Simpson's one-third rule is approximated by a second order polynomial. Therefore, integration can be represented by this equation, and instead of f of x, we are writing f to x. By this 2, we are basically representing or indicating that this function is a second order polynomial. And we also know that any second order polynomial can be represented by this equation, where a0, a1 and a2 are the coefficient of this second order polynomial. Now our next step is to calculate this a0, a1 and a2, and how we will calculate it, let us represent it by this graph. Since Simpson's one-third rule is a two-segment method, or for simplicity we suppose that Simpson's one-third rule is two-segment method. Therefore, this whole area is divided into two segments. One is this part, another one is this part. Now since a and b are the lower and upper limit, therefore at the middle point is a plus b divided by 2. And we suppose that f of a plus b divided by 2 is the value of that function at this middle point. And for calculating this a0, a1 and a2, we will consider this set of data. This set of three data. One is a, f, a. This is first set of data, and second is a plus b divided by 2 at the value of that function, and last one is your b, f of b. If we place this data into the equation number 1, we can represent this 1 and 2 by this equation, by this set of equations. Here for f of x, instead of x we are putting for the first data a, so polynomial becomes like this. For the second point, instead of x we are putting a plus b divided by 2, therefore polynomial becomes this equation. And in the last one, instead of x we are putting b, so polynomial becomes this. Now if we solve these three equations, we can calculate a0, a1 and a2, and after calculation or after simplifying or solving this equation, we can express this a naught, a1, a2 by this set of equations. Again, from the equation 1, we can write, instead of f of f to x, we can put this polynomial here, and after integration, just after integration, we will get this equation, and after putting the limit of the integration, the total integration becomes along the like this. And we suppose that this is the equation number 3. Now substituting the value from the previous slides, a naught, a1 and a2 in equation 3, this equation 3 becomes like this equation, and we suppose this equation number is 4. As I have already told you, Simpson's one-third rule, this in the Simpson's one-third rule, it is broken into two segments. Therefore, the segment which is given by h equal to upper limit minus lower limit divided by 2. If we want to increase this segment, suppose up to 10 segment, then instead of 2, we have to divide it by 10. Now, from these two equations, instead of b minus a, we can write twice s. So equation 4 becomes like this. Now here we can see that there is a 1 by 3. So this rule is known as Simpson's one-third rule. Once a function is given and its limit is given, by using this formula, we can calculate the total integration of this function. Before to that, you have to calculate h. Now there is a homework. Write down the general mathematical form needed to compute the approximate numerical solution of a finite size integral I equal to integration f of x dx using Simpson's one-third rule. So these steps are explained in this video lectures, and this question was coming in 2017.